Okay, so now we're going to take a look at how to condense multiple logarithms into a single logarithm. So we see directions like this that say to write as a single logarithm or to condense into a single logarithm. That's what we're talking about. I'm going to try to give you some guidelines here as to how I would approach a problem, at least my recommendations. The first thing I would try to do is I would look at the problem and I would see if there's any places where I could use the power property. If I see any numbers down in front of the logarithms connected by multiplication, I'm going to use the power property to move them back up as exponents. Once I've done that, then I'm going to try to use the product property. I'm going to look at any pieces that are being added, and I'm going to join those together in a single logarithm of the product of what was inside each of those individual logarithms. And then finally, if I see any subtraction anywhere, I'm going to use the quotient property to put that back together as the single logarithm of that quotient or of that fraction with that. So I'm going to go ahead and make up an example or so here just to kind of show you how this would work. We'll just put a couple properties together and see how that goes. Let's say in this particular example, let's say I had something like 3 log base 2 of x plus 2 log base 2 of y. So here I see 2 separate logarithms, and the directions want me to condense this into a single logarithm, and based on the recommendations that I just made a second ago, the first thing I want you to do is deal with these numbers that are down in front. This 3 that's in front of this logarithm, or this 2 that's in front of that logarithm. Let's go ahead and use the power property to rewrite this in an equivalent form. That power property says that this 3 can come back up here and be the exponent on this x. So this will become log base 2 of x cubed plus, same thing over here. This 2 can go back up here and become the exponent on the y. So this will become log base 2 of y squared. Again, notice I didn't do anything with the bases. I had base 2 logarithms initially, so every time I write this, I'm going to write a base of 2 with the logarithm. Don't let that confuse you. These properties work just for any base like that. So now that I've dealt with that, I have one base 2 logarithm here plus another base 2 logarithm there. The second recommendation I made after you dealt with the power property was to deal with that product property. I see 2 logarithms joined by addition. Those logarithms have the same base. I can go ahead and write that back together as one single logarithm with that base, so log base 2 of that product, x cubed times y squared. So that would be x cubed y squared, like so. And I have condensed that into a single logarithm. Okay. Let's look at a more complicated one. Maybe that has a couple more pieces. Maybe I have some subtraction in there as well, so I have to use the quotient property. Let's say maybe I have log. I'll just use the common log here so I don't have to write a base. Let's say maybe I have log of x minus 2 log of y plus 5 log of z. So again, if I was following the recommendations that I gave a second ago, the first thing I would try to do here would be take advantage of anywhere I can use the power property to move some of these coefficients back up as exponents. So I'm going to go ahead and do that now. I'm going to go ahead and rewrite this as log of x. There was no coefficient there that I had to deal with. Minus, instead of 2 log of y, this is going to become log of y squared. I moved the 2 back up as the exponent using the power property. And then plus, same thing here, 5 log of z is going to become log of z to the 5th. I used the power property to move that exponent back up with that. So now, the second recommendation I made was to take advantage of the product property. If you have logarithms that are joined by addition, maybe I'll go ahead and rewrite the order of this for a second. So this is log of x plus log of z to the 5th minus log of y squared. Maybe writing those two terms that are joined by addition first will help see this. I'll go ahead and use that product property to put this log of x plus this log of z to the 5th back together as a single logarithm. So that would become log of the product of x and z to the 5th, which is just xz to the 5th, like that, minus log of y squared. And then finally, which I didn't have in the last example, I have an instance here where I can use the quotient property. I see two logarithms with the same base. It's the common log of this product minus the common log of y squared over here. I see two logarithms with the same base that are connected by subtraction. So I can write that as a single logarithm. I'll do that over here in the corner of the board of the quotient. I have log of x z to the fifth over y squared, like that. And this would be my final solution there, where I've written this together, condensed as a single logarithm. That's just a couple examples. There's not necessarily one way to go about doing a problem. You can reach out if you have questions. If you get stuck at any point, I'm here to help.